It's an honor to be here. I'm very excited that the room seems to be too small for so many people being interested in indoor navigation. So I'm going to start with a brief introduction about ViewAR. So we're a team of 19 people in the field of AR since 10 years, meanwhile, headquartered in Austria, Vienna. And we're creating an AR framework that is platform independent, basically a C++ core that is overlapped with an HTML layer, letting you create AR applications with JavaScript APIs. And we offer a range of template-based solutions for different scenarios, and indoor navigation is one of the main topics that we address. So in terms of the agenda, I will introduce and briefly describe different tracking approaches, as in marker-based, as in SLAM, as in using Bluetooth beacons, ceiling antennas, and highlight a development that we have done on the so-called ViewAR tracking fusion system, and then compare different tracking solutions, and then talk about a solution that we created called GuideBot, and indoor navigation with an AI character. So the principle of indoor navigation is obviously to overlap the existing world with a virtual environment and to have this virtual content sitting in place on the very spot and creating this immersive experience. So a very simple but still effective approach is using markers, using QR codes. A lot of people are not a fan of QR codes, but they, let's say, sometimes do a good job, and also they're a link to an application. So if people see them, they know what to do. They'll open it and then download an application. So this is applicable if on scenarios where the environment constantly changes. So for example, also maybe you've seen our GuideBot demo in the exhibition area. If not, pass by at our booth. We had like an hour to prepare when all the booths were already set up in the morning, so we couldn't prepare any visual recognition systems. We couldn't mount anything like permanently installed. So the QR codes were basically just the QR code navigation was set up within, let's say, half an hour or an hour maximum. In terms of the main points, obviously this is a low-cost alternative and has an easy setup. And the disadvantages is that it requires a user interaction, as in find your next QR code in order to start a navigation, and that it can get damaged. And it is visible and, yeah, and maybe not ideal in all circumstances. So visual recognition systems are obviously the approach that a lot of people are looking into, and also we're looking into, and we're very optimistic regarding those approaches. So basically those systems, by movement in the camera image, they determine so-called feature points in the environment and create a point cloud based on those, and then they can relocate the user or determine where they are based on this visual fingerprint. And there are several technologies that we integrate in those regards, which, for example, is SixtyAI or Place Node. Apple Scene Recognition also offers similar capabilities for at least smaller areas. Wikitude is also offering some scene recognitions, and those run locally. And there are also server-based relocalizations where we're currently looking into integrating a system called Navis. That's a 3D scanner. You can move around in order to scan facilities, create point clouds and 3D models. And Microsoft Azure spatial anchors are also a candidate for cloud anchors. And there's another company in Germany called Visualix, who are doing similar development in terms of relocalization and point cloud-based relocalization. Google VPS is coming out. Unfortunately, there is no API yet for developers, but it works great in Google AR. I guess a lot of you have tried it already. And Niantic is also working on such a solution, mainly in the field of multiplayer. And yeah, obviously this works if the environment doesn't change. So for a museum or for tours, this is a great approach, since you can record a visual recognition and then use this recognition for relocalization. A company that I want to highlight is called SixtyAI. What they're creating is it's a mixture of local and cloud-based approach. They are creating a relocalization system that is not only doing relocalization, it's also doing 3D reconstruction. And what you can see here is a video of several people having a shared session and actually creating a 3D model of this environment with reconstruction. It's even textured. So basically, due to the ability of relocalization, they can share a session, and this 3D model those 4 3D models can then be stitched together to a huge 3D model of the scenario. So, going to come up shortly. So such a 3D model is obviously a great tool for, let's say, admin interfaces in order to maintain indoor navigation applications. And as I said before, this is not just about reconstruction, it's reconstruction plus relocalization. So this is a very powerful tool that we're integrating into our system and offering to the developers using our tool. Coming to the advantages, visual recognition systems offer high accuracy, and they're kind of impossible to be destroyed unless you change the environment, which sometimes happens. They're not visible, which might be seen as an advantage, might be seen as a disadvantage, because imagine you would be offering such a service in, let's say, a supermarket or shopping center. You would anyway want to put advertisement billboards or stickers or whatever in the environment to make people aware of the application, and these could already also serve as visual markers. Anyway, disadvantages are that it's obviously sensitive to environmental changes, and also recognition sometimes fails in terms of from different angles. Point clouds have different appearances, and those mathematical challenges are sometimes too hard for local computation, but there are technologies coming up that are solving this. Another approach that we investigated a lot is using Bluetooth beacons. Probably you've heard about Bluetooth beacon positioning, and you probably know that this has an accuracy of 5 to 8 meters, and you would say, oh, 5 to 8 meters, then I don't know in which aisle I am when I'm in a supermarket. Correct. So that's why standard Bluetooth beacons as in positioning are not that applicable for AR applications. They also just provide a position and not an orientation. Using the compass is very risky inside buildings. There are even location-based systems who identify the location according to the drift of the compass. So that's how much compasses are drifting inside buildings. And in terms of the advantages, obviously they are very easy to install. They're almost invisible. And the disadvantage is, of course, the accuracy and the tracking delay. Another approach would be ceiling antennas. So ceiling antennas is a solution. They're called directional beacon systems. So basically, they determine the angle of arrival. So if you look at a horizontal perspective, let's say from which direction it hears your phone, and from which angle, as in up or down, it hears your device. And by this, it can determine your position with an accuracy up to 30 centimeters or even less. This can also be used for tracking so-called tags. So here you see a demonstration of a guy holding 2 Bluetooth tags, and those are tracked from the ceiling above. And you can see that this is highly responsive, and it gives you the ability to not only track phones, also to track those tags. This is used also for exhibitions and tracking where people go, or in industrial environments, if you have, let's say, a trolley with a certain product being produced, where did they put it? And if you combine this with AR applications, you would have an AR application visualizing not only, let's say, paths and directions and indoor navigation, also visualizing where it is which item and identifying it right on the spot through AR. So in terms of the ceiling antennas, as I said, they provide a very high accuracy, and they're able to track Bluetooth tags and devices, as in phones, and they're almost invisible. Works indoor and outdoor, even over a few hundred meters. for outdoor installations. The disadvantage is that you have to install this hardware, and this is powered over Ethernet. So you need a LAN cable to every device, which sometimes can be a barrier, but sometimes for a fixed installation like an exhibition hall or industrial environment, it's not a problem at all. If we look at the solutions that I've presented, as in the beacons and the ceiling antennas, they just provide poses. So they just provide a position like GPS. GPS, and this is just a sample image using GPS, but it's the same principle with beacons and with ceiling antennas. They only provide the position, and this position also comes with, let's say, accuracy drift. And if you look at what ARKit and ARCore provides, it provides a very precise movement curve, let's say, of how you were moving, but it doesn't have any relation to the world, and it doesn't know in which direction you are going and where you are. But we've created an algorithm that tries to merge those two inputs and make them as accurate as possible. So this is complex mathematics that we were applying here, as in trying to determine a more accurate position. And we call this the ViewAR tracking fusion system. And as I said, this works with Bluetooth beacons, with ceiling antennas, and with GPS. And the application areas are large spaces where beacon installations make sense, or ceiling antennas are installed, or even outdoor navigation. I want to show a video of our GuideBot solution running with beacons and the fusion system. Actually, the beacon company has, before we started this development, has told us, your office is too small, it won't work in your office, that's like a too small area, it works better for airports and larger areas. But still, we gave it a try, and I want to show you a video that documents the, let's say, what's going on. So basically, for the very first positioning result, we're taking the Bluetooth beacon position that is visualized with the green arrow, and we're combining that with the compass input, but only for the very first moment. As you can see on the right side, there is still a calibration process going on, and the map is, let's say, a bit off. Probably like 2 or 3 meters off currently. And once you move around, the system does a calibration and these curve matching algorithms. And after walking of a distance between, let's say, 15, 20 meters, the system has collected samples from the beacon tracking and puts those together in order to make the tracking more accurate. So if I was in a shopping center, I would probably walk, let's say, the first 20, 30 steps with my compass in a rough direction, and now it's almost calibrated at 80% with an accuracy of 1 meter. And now I have our virtual character coming up, and the line will still continue jumping and recalibrating, ending up with an accuracy of 0.5 meter. So by this algorithm, we're bringing down the accuracy of Bluetooth beacons from 5 to 8 meters to 0.5 meter. That's 10 times as much accurate. And this is, as we see it, a huge step for indoor navigation and for the abilities, because those beacons are cheap, and they're easy to install, and you can cover large areas. And yeah, so in terms of the advantages, it provides a seamless start for users, as in they can start wherever they are and have a rough direction on an initial phase, and then it gets more and more precise. Also, you can make those Bluetooth beacons 10 times as accurate, and it also offers high precision from the local SLAM abilities combined with the positioning system, and extends the tracked area of visual recognitions. Disadvantages, it actually doesn't come with any disadvantages. And yeah, if we look at the comparison of those different technologies, obviously the QR code approach is not that cost intense, is easy to install, pretty accurate, and pretty user friendly. The visual recognition is also, let's say, very cheap to install. Basically, you just walk around, film the environment, and it records a fingerprint. The installation is also, let's say, fairly easy, not as easy as QR codes. The accuracy is higher than with QR codes, and the usability is better or not. It depends on, let's say, how well the relocalization in fact works from different angles and how robust the relocalization works. Bluetooth beacons, they cost a bit. Still, it's about 15 to 20 euros for such a device, and you would need them within a distance of, let's say, 10 meters. And the installation is quite easy. You just stick them onto the wall, and they last for 4 or 5 years with battery. And the accuracy is a bit low, and the usability has 2 stars on this. Ceiling antennas are obviously the most cost-intense approach, and also the installation is quite tricky and requires quite a bit of effort. The accuracy is pretty high, and the usability is mastered by this approach. And now you would say, who's the winner? And actually, it depends on the case, it depends on the environment, it depends on the circumstances that the location has. Budget is always also a topic, and time. And yeah, coming to the second part of the talk, which is more going towards application types and also introducing our system called GuideBot, which is a virtual character that pops up in a store. I'm going to play this video. So this application is using chatbot technologies in order to interpret speech and determine the POI of the user's requirement. And then it's guiding the user to this POI. And later on, in this case, it will be introducing a product. Obviously, this could be used for various application types. And this is provided with our system as a so-called template. So we provide this with full source code access, so you can customize this to your needs with using JavaScript as a development language. So as I said before, the viewer system is basically an SDK that has an HTML layer for the UI, and the application logic is done with HTML and JavaScript. So this is a very easy step into the field of AR. In terms of the visual recognition, I want to show a quick video that shows you how to create such a map, as we call it. First, you log in with your credentials, and then you click on Create New Map, and then you enter a map name, and then you set up a kind of a streets network. So you set up the waypoints of where the bot is able to fly, and mark the point of interest. Also, keep in mind with the visual approach, obviously we should not only film the floor, we should also film the environment in order to let the application learn the visual appearance. Yeah, so here we are placing a few waypoints going this path. And the system will later on, even with multiple waypoints and with huge maps, it will automatically pick the shortest path from the current waypoint to the point of interest on this street network, on the waypoints. And here you're seeing the point of interest being recorded. That's basically where you're holding your phone. And you can enter a description and a name and save that to the cloud. It will save the waypoints, the POIs, and the visual recognition pattern. And now we're restarting the application, which actually makes all the tracking information, let's say, being reset. So the application doesn't know where it's at unless you now load this map. And now it's loading it's displaying the overall map perspective, and then it's doing a relocalization. So if you film around, the map is re-established. This is like live footage from recorded on an iPhone. And yeah, you select the point of interest you want to go to, and the robot will start flying and guiding you. Again, this is, let's say, a platform that we provide to let you as developers and agencies and companies come up with creative ideas of how you want to use this. A customer that I want to briefly highlight is SBB, which is Swiss Public Train. They're currently testing our system for technical maintenance. Actually, they're building an AR platform that should be used by 35,000 employees, and it's built on top of the ViewAR SDK, so our platform, which makes us very proud. And indoor navigation is one of the topics. So, yeah, a quick summary of the guidebot template. It comes with the features of navigations, waypoints, and point of interest, AI chatbot connectivity, voice input, voice output. We have a feature for tours. We have an admin interface that lets you define waypoints, POIs. This is yeah, a scan of the SAP office. The web version for the for maintaining the maps, and the app template comes with customization abilities, either for non-developers using our app builder or for developers with full source code access. And you can even customize your own 3D character and input it to the template. And yeah, it works with marker-based trackings, it works with place node, it works with SixtyAI, it works with beacons, with ceiling antennas like Coupa, and even with GPS. So thanks for listening, and hope to see you.